All right. So we started off class with this. Ooh, let me do the back button. Back. There we go. Started off with this silly little question. And of course, the answer is what, everybody? Say it. Skunk. And it's just a stupid little equation there that just emulates what they call one-to-one properties, but you don't have to write that as that name. But sometimes equation solving is just by matching the pictures or matching the symbols with what number is in the same position of the variable. And that's the case that we've already done with exponents. Like we had questions like this. I'm going to make it as simple as possible. Ooh, I'll ratchet it up a little bit. 3 raised to the x minus 1 equals 9. Well, what do we have to do to 9? Make it what? 3 what? So you make it something that's equal to 9, which is 3 what? Squared. And then this is not any math. You're not doing a mathematical operation to the 3's. You're just saying if 3 to this power equals 3 to that power, the only way that's true is if this power equals that power, if you have equal bases. Well, now this is one of the scenarios, let's say, for logarithms. And it may come down, let's say half the time, although that's not necessarily true, that it comes down to an equation where you get log, I'm just going to leave it like that, of x minus 3 equals log of 12. You don't have to know anything about logarithms. As a matter of fact, I wrote this down once on our notes earlier in the year. The only way this is true is if what? If x minus 3 equals 12. I didn't do any logarithm work there at all. All I did is match and say, well, if log of this equals log of that, the only way that's true is if this equals that. I didn't do any logs. I didn't do any nothing. I used like a matching. Okay, and then of course x equals 15. So no logarithms done there at all. It's just a matching kind of thing. I don't know what else to call it other than matching the spots. Ah, I lost my sneeze. I hate when that happens. It just ruined my day. So this is what you're gonna, and this is kind of all over the place, but not really. You could have a couple things happen when you're solving an exponential, which we're going back to that. We've already done it, and a log. And the first scenario could be what we just discussed. If you have log equals log, drop the logs. You're not doing a math operation. You're just saying if log of x equals log of y, then x has to equal y. It's common sense. That's a good way of saying it. Just like in exponential scenarios, if b to the x equals b to the y, well then x has to equal y. Again, I could have my 7-year-old figure that out. But then there's other times where that's not the case. So let's imagine we have this. 3, this is for step number 3 here. 3 to the x equals 7. I can't write 7 as 3 to a power just in my head. So then what I have to do is do logarithms. And I will have to use... Oh, I should have asked you this. Oh, I already started. So when I put the word log in front of this, the base is 3. So log base 3 of what? What's next, everybody? 7 equals what? And I don't care if you think I'm mean. I hear all the things out in the streets. The streets being by the lockers. All right? Swear words with Mr. Samuels' name in it. If you do not know how to change it, son of a, I was right in the middle of something, and this thing always interrupts me. All right. If you do not know how to change a logarithm into an exponent, then you will fail my test. You will get an absolute positive flag. There's nothing I can do for you. Nothing. So make sure that you do get that down. All right, and then if you do get it down in the log form, then change it into exponential. For instance, log, let's just say that. And it could be just about anything except x over there equals, I guess I could do this without a calculator, but maybe not. 7. So what would x equal? Well, I don't know, but what can I do? Well, what's down there as a ghost, by the way? 10. Did you hear that? And then, so I get rid of the word log, and what happens? 10 to the 7th what? Well, guess what? You got x. And actually 10 to the 7th is a 1 with 7 zeros. So you could get that answer without any calculator. All right? That's what that one means. And then this last one actually coincides with, don't look at that assignment because then some people start doing it. This last one correlates with step number 2. Sometimes you're not ready for step 2. If you have several logs in the equation, you're going to have to rewrite them as a single log and then convert them. And then now that's when I'm going to go to our calendar. That's why I was there, to remind you of some rules that you better remember. I forgot to have this hyperlinked earlier. Remember these? And you might want to write these down. Because what we will get is students that kind of mess this up. So don't forget these rules that we learned in 3-4, because they're going to be used today again, when appropriate, of course, when this comes up. So we have that possible drop your log situation. Log equals log. But you can't drop the logs if one side has more than one log through the sum rule or the subtraction rule. So what you have to do is condense these words that are gone. This is condense, this is expand. You want to get it in condensed, son of a nut. Change it. What do I actually type? Don't show this message again. Got it. You all right? All right, so that's what you want to do. You want to use those rules to get it in condensed form. I'll let you write those down if you're a note taker. Pretty much was it. Okay. All right. So, talking out loud. This is we've already done these kind of questions, and yeah, your students got to be mathematical in nature as far as thinking about numbers. So Jerk Mr. S puts this on the no calculator test. Oh, and I'll have a no calculator part. So look at my face. All right. Try to tone it down. It's first day of spring break. I won't be full Samuelus. Just not too bad. But yeah, look at my face. This isn't a no calculator. So what's 3 times 3, everybody? 9. What's 3? He's already got it. What's 3 times 9? 27. No, 3 times 9. And then 3 times 27 is now. All right. And then what do you think 3 times 81 might be? But what's 3 times 8? What's 3 times 80? 240. So 3 times 81 would be the 243. So yes, this is 3 to the 5th. Okay, so you're stuck in log mode. This is an exponent, so I'm going to change it to a log. Blah, blah, blah. So let's remind those students, what does this become? What do I put down here? What goes in this position? If you don't know this, it's your fault. And then what? 243 equals what? So, okay, but it's in the no calculator part. And you look at maybe the answers, and it's just numbers. It's not numbers and, it's not a log answer. So, okay. Well, you just said it. 3 to what power equals 243? The answer is 5. So in one way, shape, or form, you got to know that without a calculator. Or, and then we'll get an answer. Or you take this back, and it's 3 to the 7x, and you change 243 to 3 to the 5th. Because that's what it is. That's what it's equal to. And then you drop the 3's just because of the matching rule. I don't know what else to call it. They call it the one-to-one property. Fine. Either way, we're back in the same spot, and you still get x equals 5/7. And it's all done without a calculator. So let's move on to the next one. Everyone okay? May I go on? All right. So did I really need logs on that? Not really. Okay, and then here's this one. Now, the reason I like this one is this, I think, is actually one of our equations that we had back in 3-3. And then we had to do y1, y2, and find the intersection of these two graphs, which actually takes a long time. And not every student is real good with the graphing calculators yet. But it does take a long time. This does not. Oh, by the way, is this 40 raised to the t? Should I multiply these two? Never! The 20 is not raised to that power. So what should I do with that 20? Okay, now we're getting somewhere. Without a calculator, you're mean, Mr. S. 100 divided by 2, 50. Now, can I write 50 as 2 to a power? Can you or can't you? You can at least do this. What's 2 times 2? 2 times 4. 2 times 8. 2 times 16. I'm showing my fingers up. And then what's 2 times 32? So where should the answer be between? See, I could do that. I could have multiple choice and only one answer is between 5 and 6. That could be done. And then I'm making the student think without a calculator, what is going on here? What am I actually answering? Or I could do this, which is more likely. Tell me, I'm waiting for you. Log base what? 2 of who? Equals what? And then that's what I could have listed in the multiple choice in the no calculator section. Because all that I'm asking you is, do you know how to, after not having something I could change bases and make them equal, do you know how to make it as a logarithm? Do you know those positions? And then, of course, we could type that on the calculator. If this was in the calculator portion, I swear this is still easier. And some of you might ask me, where is this button on my calculator? And I'm not going to answer it. Because everyone on any calculator that has a logarithm can do this by the change of base formula, which I did teach in section 3.4. Log of the answer, in this case, which is 50, close the dang parentheses, divided by log 2, and you don't have to close that. You can be lazy, but I won't be. Okay, does that answer make sense, at least? 5.64. It is definitely in the range. Love that word, output. Okay, maybe just to show you the bad notation in this book. That's the book's typing. So you got to be able to read that and say, okay, 20 to the 1/2, not bad, but this is just old school fraction work. This actually isn't as bad as some of them. I think that you could see is in an exponent. So again, I'm not even going to bore you. You don't multiply 20 times 1/2. It's illegal. Now, I did have someone last hour mess this up, that they're doing really well in the class. So just to share that word with you, that this is a common error how students do this in the non-calculator portion. What is the common base? It could be 1/2, or you could take it further and say 2. Like this, 2 to what power equals 1/2? 2 to what power equals 1/2? So you could change this to 2 to the -1, but we'll stick with 1/2, and then this is what you got to be careful. I got to replace 1/4 with something that is equal to 1/4. So what is 1/4 equal in terms of 1/2? See, that's where we have two different answers. Someone said -2. Someone last hour said they tried to do a fractional exponent thing. What do I simply have to do to get this to be 1/4? Square it. So this is 1/2 raised to the x over 3 equals 1/4 equals 1/2 squared. And in equation solving, as long as you put something equivalent in the position, then it is still a balanced equation, is the best way I could say that. So you got to be careful on that. And then you could drop the half. That's let's say the one-to-one property that the book calls it. So x equals 6, and you could always check this. Okay, everyone, I like to do this. What's 6 over 3? 2. Did you answer that, sir? What's 1/2 squared? 1/4. What's 1/4 of 20, do you think? Check. Okay, so it worked. Oh, now it's time for logs. I love it. And I hope you had these a little bit last year. You had to have. I know the other teachers were bragging how big we were with logs in Math 3. Bragging. All right? Can I just go, blah, blah, blah? Can I just change this to an exponent? No, I hope you realize we have a bit of a mess. Like we have this. How do I deal with this 3 then? Sometimes students mess this up. 3 minus. What do I do to get rid of that 3? It's just subtract. Those that make that mistake, you got to stop. It's not divide or whatever. It's 3 minus. It's actually 3 being added to negative log blah, blah, blah. So that's how you get rid of that. And then that means you have a negative here. So how do you deal with that? Divide. So I'll do that in red just so it shows up for those looking up and down. Where'd you get that? Okay. Now, do I do this property where I drop my logs? Do I drop the logs? Do I just get rid of the log? And that's what students do. This is not one of these scenarios. This is not log equals log. All right, so no, you don't just drop that log. What do? Okay, what's this number right here? And then what is it, everybody? And then now we're going to get real annoying. Not real annoying. This is actually my job to teach math, or at least, what if this is on the no calculator part, right? What's 10 to the negative second? I'll start it. 1 over 100, because it's 1 over 10 squared. And then I have to subtract 2. Your mind's going to get blown here. What's 2? A number. A 2 is what over 100? See? And no one should have a problem with that. Someone answered that in a millisecond. And it really should be everybody. Because then if I was a jerk and this was on the no calculator part, what's negative 200 plus 1? And then that just emulates that I've been teaching fractions all year long, and every student in this class should get it right, or else. All right? So I got a common denominator so that I could go ahead and actually physically subtract these in this case. All right, let's get a motor on. Should I do 3 times 4? Don't be ridiculous. The reason I like this one too is the whole equal basis thing. Now I know I could change this to a logarithm. Log base 4 of 32 equals x over 2. But, oh, I thought he was, are you sleeping? Oh, you're not. Are you sure? There's a long blink. Okay, look like, all right, good. We're almost done. What's the common base? I heard her. Anyone else agree? What's the common base that 4 and 32 have in common? What this number to this certain power equals 4, and the same number to a power equals 32? Well, I guess you're alone. What'd you say? Say it out loud. 2. I can't raise 4 in my mind to a power to equal 32. What's 4 squared, everybody? 16. Answer the questions. You'll stay awake better. What's 4 squared? What's 4 to the third? 64. You just miss. All right? So we got to get this into bases that are common. What's 4? 2 what? What's 32? 2 to the what? Do your fingers. 2 to the fourth is 16. Hey, then guess what? What do you do with these? What do you do with these? Multiply them. So this equals this. What's 2 times x over 2? The 2's just cancel, everybody. I had those invalid mathematical fractional operations going on again. The 2's just cross cancel, and you just get up with x. Aye, fractions all year long. All right. Yeah, that's right. That is his name. Okay. All right. So how do I do this one now that everyone's talking about the shark stories? Okay, let's get this done. So what's this? What's this? I see before my eyes. What is it? 10. So what do I do? 10 to the second equals x squared. And then just so you, what does that mean x equals? Burn! No, not 2. Plus or minus 10. When you square root to solve, you got burned again. You remember that fire? We were talking about this last time. Remember that fire I put on your test? How many people got burned? I drew fire on your test. Do you remember that or no? Burn? See, only a couple remember. It was like 8 of you in this class. And the reason I did that is you learn when you get burned. But some of you aren't learning. All right? Still not learning that you plus minus when you square root. By the way, though, got to worry about negatives working with logs. Does this negative 10 work when I plug it in? Actually, it does. You know why? What happens when you plug in negative 10? What do you do next? Square it, and that becomes what? It becomes a positive 100, so it's okay. Just remember I said that with logs. You got to be careful. Now we got a problem. Okay. And then I'm going to make a comment about this. What students try to do when they learn something maybe new, although this shouldn't be new, They just grasp at concepts that I said, oh, this is what you do when you have this. And the biggest error that you'll get no credit for this is, oh, he said when there's more than one log, I drop my logs. So I'm going to drop my logs right now. That is so wrong. Okay? You don't drop the logs. You use the one-to-one property if it emulates the horse times skunk equals horse times X property, which is what I'm going to call it. Which means if I have log equals log, then I drop the logs because it's just matching. This is not the case, and I'm trying to save those students that will still do this for some reason, because every year that I talk about this, they make the same mistake, and I do want to cry. So what do? She set it up in the front. Okay, what's the rule that says what I can do when I have ln plus ln? ln of multiply. Oh, that was said so bad mathematically speaking. And then what do I do with this 2? Because it really shouldn't be there if I'm trying to condense these. What happens with that 2? It becomes a what? An exponent. Now I have ln of this equals ln of that. The only way that could be true is if this equals that. I didn't do anything mathematical. I didn't do blah, blah, blah. I did nothing. You could call it that. There is something we could do, but it's a little bit more confusing. Believe me, it is. We could change this into an exponent and then use one of our properties from 3-4 that you're not more than likely going to remember. And then we're going to FOIL. I'm not here to teach you FOILing anymore. Not here to bother you with this. As I write this down, you should be like, yeah. When we have squareds, we should get it equal to 0. And then we should try to what this? Because it's faster if it is. And it actually is. Let's see if someone can tell me what it is. That's the MA numbers, but really what we need is the factor. So that would be your process of going 4 steps to factor. I really think this should be this. It should be a 2x and a 1x, and then you should think, what is this one? Minus. Now, it wouldn't be minus 2 because then there's a greatest common factor, which there's no greatest common factor in the original. That's another, I don't know if anyone caught that real quick, but that was true what I said. Now, what does that mean x equals? 1/2, right? And 2. And then we're going to circle that answer, right? Ooh, what'd you say? This is an expert up here. Everyone else, circle these answers, right? She said what? Check them. And really, you don't have to check them. I understand there's time issues. Maybe 10 years ago, those students checked all their answers, and, they were real nice to their teachers. And never mind, sorry. You guys are nice. Some people in SSR don't do the rules. 2 times 3 is 6. What's 6 minus 2? Is that okay? Can I ln 4? Would that give me an output? Yes. 2 minus 1 is what? ln of 1. By the way, what is ln of 1? We should know that answer. It is 0, e to the 0. And then 2, don't try to answer that one, but that works. Here's what doesn't work. Let's put it right here. What's 1/2 minus 1? Negative 0.5. Can you ln a negative? Now it's time to share the things you can't do. You cannot ln 0. This is not possible. This gives you, they say, not real answer on your calculator, which I should be able to analyze, but I can't think of why that says that. And you can't ln a negative because what you're doing is e to what power equals a negative. It's impossible. So that's an extraneous solution. You did valid math. This solution solves this, but it doesn't solve that. So therefore, I can't use it. That's what extraneous means. All right, let's move on. Oh, here's my last one. Now, is this a drop your logs? Oh, whenever I see 2 logs, I can just drop them. I'm going to get people doing that because they're robots. Okay, so what do I have to do? I have to change this to what rule? Division. But what else do I have to do with this? This turns into an exponent. So you feel free to write the whole question down. This is what I expect the student that likes to, that's the question on the test. You do these couple things, and then you use the division rule. By the way, what's x plus 4 raised to the half the same thing as? I asked this last hour and I didn't get a really good response. What's 1/2 power the same thing as? No, not negative, not flipping. It's not a negative exponent. It has nothing to do with that. It's a square root. And then again, I tell those students, you're not doing bad because of logarithms. You still don't know your exponent rules. And we actually went over these rules earlier in the year, and you had them before. Okay, is this a drop your log question? Robots? No. I don't have log equals log. I do have log what? And then what can I do next? 10 to the first equals all that junk. And then because I'm on the video, I bothered students. I bounced around the room. But what do I do next, everybody? Multiply by square root of x plus 4. Ooh, I'm at an impasse. What's causing me the big problem, though, is this. How do I undo that? What do you do to both sides? Not square rooted. That'd be a double root, right? You square it, right? Notice how I put it. Notice how I put it. What else do you square, which is what students mess up all the time? The 10. So this is 100 times a free x plus 4. That's how that works. You square 10. When it's a product, you do square each part of the product. And to square this just means that they nullify each other. Equals x squared. And then you can distribute and subtract. And I'm going to stay blue. And then, unfortunately, this is not minus 400, right? 400, and then I have to subtract it. This is not what? Wah, wah, wah. Not what? Factorable. If it's not factorable, then what do we got to do? 100 plus or minus square root 100 squared. I ignore the negative because a negative squared is a positive anyway. Minus 4ac. We did make a mistake the other hour. They didn't say a word. Those bums. They are bums. Bums, bums, bums. Last hour, it's minus 4ac. Isn't c a negative, right? So either last hour I put a plus here, or last hour I didn't do a negative times a negative. So what's negative 4 times negative 400? 1,600. So this is 100 plus or minus the square root of 1,000, no, 10,000, wait, 1,000, I was never good at math. This is going to be fun. So 1,600 plus 10,000, isn't that 11,600? Oh my goodness, over 2. At this point, I think I simplified. I'm tired. Okay, you can get the decimal, but here's the problem. Now, a second hour, can't even think of what they're. Are these answers, do they work? Now, I know you're not going to plug it in and see if you get 1 when you do this. What you better do, though, is assess what 100 minus the square root of. And it is going to be a negative, right? How do I know it's going to be a negative? What's the square root of 10,000? What's the square root of 10,000? 100. So it's the square root of something bigger than 10,000. More than 100, so this is a negative. So yeah, second hour, we made a mistake, and actually there's only one answer that's valid. It's the plus one, because the one that has a minus in front of it gives me a negative, and I can't take log of a negative, and that position alone right there screws it up, right? So even though we did a quadratic formula, like, oh boy, I don't think you have an extraneous solution in there. There is, all right? And that's how we're going to end it.